Okay, for today we are going to be talking about inscribed angles. So first we need to know what an inscribed angle is. So I tried to show that here in blue. An inscribed angle is an angle whose vertex is on a circle. So if you look at it right here, there's the vertex of the blue angle and whose sides contain chords. Okay, an inscribed angle, we say, intercepts an arc. It's kind of like a mouth eating a part of the circle. So you can see here I tried to do that. So if I said this was 90, which it's not, then we would say this angle was 45. That's coming from here. An inscribed angle is equal to half the measure of the intercepted arc. So for example, if this arc was 90, this angle would be 45. And there's some proof to that I'll show you probably tomorrow since I'm not in class today. For the next theorem, if two inscribed angles intercept the same arc, then the angles are equal or congruent. So if you look at the blue angle here, it intercepts the yellow arc. The green angle also intercepts the yellow arc. Well, we know these angles are half the intercepted arc, so they're half of the same thing, therefore they have to be equal. An angle inscribed in a semicircle is a right angle. Okay, so here we have a semicircle. Well, a semicircle is 180 degrees. And if the angle is intercepting a 180-degree arc, it is half of that. So half of 180 is 90. So any inscribed angle that intercepts a semicircle is going to equal 90 degrees. Now in the last one, this comes out a little crazy, but if a quadrilateral is inscribed in a circle, and we already talked about the definition of inscribed, then its opposite angles are supplementary. So right here I'm going to focus on angles 1 and 3. I kind of outline those in blue and green. So angle 1 intercepts the yellow arc. Angle 3 intercepts the pink arc. And we know, because of the theorems above, that these angles equal half the measure of these intercepted arcs. So instead of looking at them individually, because I don't know what yellow is by itself or pink by itself, let's look at them all together. Well, yellow arc plus pink arc equals 360 because that's how many degrees are in a circle. Well, angle 1 plus angle 3, those together equal half of that. So half of 360 is 180. So 1 and 3, 1 plus 3 will equal 180. The same thing will be true about angle 2 plus angle 4. Okay. So now we're going to look at some problems with these, hopefully. Okay, oh, we got one more to go. The measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. So these are two chords, and the measure of angle ABC is half the intercepted arc, and the intercepted arc here is AC. The same thing is going to be true over here. This is now a little different. It's not an inscribed angle because it's made of a chord and a tangent. So the intercepted arc here is going to be XY. It's going to be from X to Y, like this. And it's still equal to half of the arc. So if you look at angle X, Y, Z, and kind of see that as, again, almost like an alligator mouth, I guess, and what part of the circle is that eating? Okay, this part right here from X to Y. And this isn't really going to let me draw on this today, but so it's the same idea. It's still equal to half the intercepted arc. So here are some problems, and what I would do is start by kind of finding, like, this is an angle of 20, trace that down to find the intercepted arc. And remember that the angle is half of what the intercepted arc is. So what I'm going to ask you to do is to work on these, push pause, work on these for a little bit, try your best, and then come back and check your answers. So at least try these, please, before just watching the rest of the video. So push pause now. All right, over here, it's a little messy, but I think I have it here. I started with the yellow here, and I knew this angle was 20. So the intercepted arc should be double that. So that's where you can see I did that. For angle Y, you can see I kind of traced out where the chords went to find the intercepted arc, which is here in purple. Okay, Y, I just found X was 40. So this intercepted arc is 110 plus 40, and then to find the angle, I take half of that. So I got 75. In the next one, again, this angle is 20. So I went out to the yellow arc and said the yellow arc must be 40 then. Well, if you look at x, the yellow arc and the red arc are the same thing. So x is going to equal the same thing as the yellow arc. So it also equals, or the yellow arc here equals 40. So x is equal to half of that, which is 20. Angle y is one of those inscribed in a semicircle. It's half of 180, so it equals 90. Okay. Out here you can see the differences again. I started here where I had an angle measure. You can actually do this problem in several different ways. Some of you may have started with looking at this angle here because you knew the intercepted arc was 140 and said that angle was 70. So there are a lot of different ways to approach this particular problem. In the end, though, I found because the yellow angle was 60, it intercepts this yellow arc, which is 120. X also intercepts that same arc. You can kind of see the green and the yellow are exactly the same arc, and x is equal to half of that, and x is the angle between the chord and the tangent, so x is equal to 60. To find the arc over here, this pink arc, I did 360 and I took away the 140 and the 120, and I got that the pink arc is 100 and x is equal to, or y is equal to half of that, which is 50. All right, over here we're applying something from yesterday and something from today. Angle x, I went out, it intercepts this arc, which is 80, so angle x is half of that, which is 40. This is a semicircle, so 80, if you have 180, you take away 80, you're left with 100. Now notice here we have congruent chords. Congruent chords have congruent arcs. That's a topic you did yesterday. So if this arc is 100 and this chord is congruent to this chord, that means this yellow arc is also 100. And then you can see how I got angle y from there. All right, here's another set of problems. Again, big part here is that congruent chords have congruent arcs, applying what we did yesterday into today's topic as well. Okay, so if you need to pause, you can see the different problems. So I'd like you to copy them down, give them a try on your own, and then come back and we'll check your answers. So please push pause now and try these on your own. All right, I didn't show all the colors this time. For angle x, or not angle x, arc x, okay, that's intercepted with the 80-degree angle. This is half of what the arc is, so the arc must be 160. Then I took 360, I subtracted arc x, which was 160, which left me 200 degrees. Because these are congruent chords, x and y, or y and z, excuse me, are congruent arcs. So each of them must be 100. Okay, over here, same idea. 60 is the intercepted arc of angle x. Angle x is half of 60, it's 30. Then I took 360, I subtracted this 60-degree arc to find the measure of both of these arcs together, which was 300. Congruent chords have congruent arcs, which means arc Z is half of 300, it's 150. In this one, again, there's a lot of different ways to do it. One of the things I used was the theorem stating that the opposite angles in an inscribed quadrilateral, a quadrilateral inscribed in a circle, are supplementary. So you can see I did that here to find out what angle X was. Okay. Since these are congruent chords, these are congruent arcs. Okay. Well, angle Y is going to be half the measure of this arc, and angle Z is half the measure of this arc. And the arcs are equal, so they're half of the same number. So you can kind of see I did that here. Okay. All right, so go back to the announcement. You can check what the problems are you can work on for today. Thank you.